Hi, and welcome back. So let's dig into properties. Now, as I mentioned in the previous video, in languages like Java, we always use getter and setter methods, accessor methods essentially. In Python, we can use, and we've been using, bare attributes. So what do I mean by that? Well, it's just what we've been doing so far before. So if I create this person class, we can do our init method. So it's going to be bound to whatever object's being created. And we can set self.name equals name. So name is a bare attribute on the instance. We're going to find name as an attribute, as an entry basically, in the dictionary for person. So if we do that, we can go ahead and create an instance of the person class, passing in Alex. And if we look at the dictionary, you can see that it contains that key value pair. So a typical method in a language like Java is to say, no, you cannot access name directly. And the reason for that is we may want to have some, let's say, validation on when we set the name. And we want to make sure that when somebody sets the name, because once the object is created, we can set the name equal to something. And maybe I'm going to set it equal to 100. That's fine. Or I can set it equal to an empty string. That's fine too. And so now we want to put in some code to avoid those kinds of settings. We want to say, no, you cannot specify a non-string and the string has to be non-empty. So in that case, using a bare attribute doesn't work. You have to use a getter and a setter method. Now, in a language like Java, you typically start off by always writing getter and setter methods for your attributes, for your properties in the class. And then you use what we consider a private variable to hold the actual value itself. What is a private variable? Well, in object-oriented programming, when you create an instance of a class, you have access to the attributes in the class as long as they are public. Now, if an attribute is private, you do not have access to that particular attribute or property from outside the class. From inside the class, sure, it's available. But from outside, you can no longer access it. You can't read it, you can't set it. Python doesn't have that. Python doesn't have this concept, if you're familiar with, of private and public. Everything basically in Python is public. So anything is available from outside. So we don't have that approach in Python where we create a private variable and then we create setter and getter methods. Now we can mimic that. So let's go ahead and try that out. So we can mimic this and it's going to be very similar to how we were doing it. So let me go ahead and say self.name or common name. And then we're going to say self dot. Now, I don't have anything private. So instead, we use a convention where the underscore that precedes the name, the attribute name, will signify to people using our class that underscore name is a private. It should be treated as private. It shouldn't be modified or accessed directly. Now, of course, this is Python. If you want to do it, you can. But if something goes wrong, it's not the person who created the class, who wrote the class, it's not their fault because they're basically telling you, don't mess with this, it's a private attribute. So in this case, I'm going to set my private attribute name and it's really pseudo-private. I'm not going to belabor the point. I'll keep calling it private from now on, but it's not really private. And I'm going to set it equal to whatever value gets passed for name in the argument to the init. So now, because I don't want somebody to access underscore name directly, I need to provide functions to get and set that name. So let's go ahead and do it. Let's do a get name first. So that's the get name method. And that's very simple. It's going to return self._name. Then we need the set name method as well, which is going to take self, let's say, and a value that gets passed in, which is going to be the new value for the name. I could have called it name. I'm just calling it value. And here I want to do a little bit of validation. I don't want to just say, self._name equals value. If I'd done that, there's really no use case for using a getter and setter. Just use a bare attribute. If that's all you're doing, just use a bare attribute. There's no need to write getter and setter methods. Because unlike Java, as I mentioned in the video, later, if you do use a bare attribute called self.name, and later you want to use accessor methods, we can do that without breaking the compatibility, the backward compatibility with this class. We're not breaking the interface. And so we'll see that in a few minutes. So here, I'm not going to just set the name to the value that gets passed in, I'm going to check, is it an instance? So if is instance value comma string. So first of all, it has to be a string, and I want the length of the value dot strip. So I'm going to strip any leading and trailing white space from the string. And if that is a length that's greater than 0, that means this is a non-empty string. So it's not a string that's empty or only contains spaces or things like that. Then I'm going to accept it. I'm going to say, yeah, that's fine. And then self.name is equal to the value, but I'm also actually going to strip it as well. So I'm going to remove any leading and trailing white space. Now, if that's not the case, right? If that's not the case, then I want to raise a value error, and I want to give some error like name cannot, or name must be a non-empty string, something like that, some meaningful message. Now that I have this class, I can go ahead and create an instance of that class. But before I do that, I want to point out what I did here in the init. You see in the init, I set the private variable underscore name directly to whatever was passed in, which means that I can now create an instance of a person class with a name that's technically not valid according to what the setter would allow me to do later. So I really want the same validation to happen here in the init. Now I don't want to rewrite the code. All I need to do is just call the setter. So instead of setting the private variable here directly, the private attribute directly, I'm going to say self.set underscore name. So now I'm going to call the set name function, but bound, so a method that's going to be bound to self, and I'm going to pass it the name value that I'm trying to set. So this way, when my init method runs, it's going to call the set name method bound to the same object, and it's going to try and set the name. If something goes wrong, I'll get a value error. So I'm getting the validation here basically for free. So this is usually a better approach. You can certainly use the bare attribute directly in your init, but very often if you've got logic in the setter that you want to run when you're doing the class initialization, then you'll want to use the setter in here as well. So that's all I did. So now we can go ahead and create a person class, and let's use Alex. So that's a valid string. We didn't get a value error. Now, however, if I try and do a set name and set it, let's say, to an integer, then I am going to get an exception. So I can trap the value error exception and then just print it. And as you can see, we get our value error exception happening. Now, the same thing would happen if I tried to make a person, let's say, with a name containing just no characters in the string. I would still get the same value error because this is running me through the same setter method. Now, of course, again, just to reiterate, underscore name is not private. We still have p.underscore name. In fact, if we look at the dictionary, you'll see that underscore name is in the dictionary in the namespace of the instance p. So, we could bypass the getter and the setter and set the underscore name property to an invalid value, and it would work just fine. But it's an underscore in front, we shouldn't be doing it. Okay, so this works. This is how we can basically create, properties in a class using getters and setters. And this is how it's done in Java. You create a private variable, and then you use getters and setters to get and set the value of that private variable. But that's kind of a pain, because now in order to use it, you saw what I had to do. I have to say p.getName. So if I want to get the name, I have to call p.getName. If I want to set it, I have to set, p.setName Eric, for example. And then I can p.getName again. And so, it's much nicer if we can just say p.name equals Eric and, or use p.name somewhere else when we want to get the value out of the instance. That's a much better way of, writing our code. It's a little bit more expressive. So Python has a way around that. And this is why when you write properties in classes, for instance properties in your objects in Python, you start with bare attributes. Just call the attribute .name. Self.name equals name, just like we had right in the beginning. We start there. Later, if we want to use accessor methods, then we can do so, and we'll still be able to use p.name and setting it and reading it just like we're doing over here, right? That's still not going to change the interface, so we'll be backward compatible. So the trick is always start with bare attributes, unless you know right away that you need accessor methods because you want to do maybe some validation, or maybe you want to do some calculations, whatever it is. But start with bare attributes if you don't need that. And then later on, let's say a month down the road, maybe you do need to start putting in some validation or something. Then you go ahead and you create properties, and it will still be accessed by using the .name, either to set or to get. So let's go ahead and try that out. And to do that, we're going to use a property object. Property object is basically an object that has the type property, and it is a special, it gets handled kind of in a special way when we use that in classes. So we're going to use the property function. Basically, this is a class, a way of creating a new instance of a property. So if I create this, I'm not going to put in any arguments when I create the property, but I am going to get an object back, and I can look at the type of the object. And as you can see, the type is property, right? I could have done A equals property, and then we could look at A. And A is just a property object, so an object of type property at this memory address. It's just another object. So let's use that in our class. So I'm going to take the class that we have already. I'm going to take this one over here, and I'm going to just paste it. And I'm going to do one little change just for now, and we'll come back to this. I'm going to use the backing variable. I'm going to say self._name equals name. So I'm going to go back to that, which means right now I don't get the validation during the initialization of the class. But we'll come back. Next, what I want to do is I really want the property to be called name. So I'm going to say name equals, and I'm going to create a property instance. I'm going to create a property object, and I'm going to specify two arguments to the property object, the getter and the setter. So I could pass them in as just positional arguments, but I'm going to use keyword arguments. So the first one is fget, and the second one I'm going to use in this case is fset, which is the set name. So what this does is this creates now an instance of a property object, and it sets two values in there. It sets basically the functions that I want to use. Remember, at this point, getName is just a function in my class, and it's going to be set on the property. Now, when I call the property later, those will get called as bound methods, bound to whatever object I'm calling the property from. So now that I have this, let's go ahead and actually use it. So let's say person Alex. So now what happened is that I have my dictionary that contains the underscore name. Okay, that's what we did in the init. Now I can recover the name property, right? So remember, what is name? Name wasn't in that dictionary, but name is in the class. So p.name, Python looks for it, doesn't find it, but it realizes that name is a property object defined in the class. So it's going to do something special. It's going to handle that in a special way. It's going to say, oh, okay, you're trying to get the name of P. Well, name is a property object on the class, so I'm going to call getName bound to P. So it's going to call this as a method bound to the object P. And so when we do that, we get the value back. In fact, we could put print statements in here, getter called, and then we could put another print statement here, print setter called. Okay, like so. Now, when I call p.name, so I'm accessing this property name, you can see the getter was called. And so you can see the way that I access the property name is the same as the way that I was accessing the attribute name. Now, this was the getter. We can also use the setter. So we can say p.name equals, and let's say Eric. And as you can see, the setName method was called. It was called as a method bound to P. And so P's dictionary, you'll see that the underscore name has changed to Eric, because that's what we do right here. We set the underscore name to the value. So that's how properties work. Now, the getAttr and setAttr methods work exactly the same way. I can say get attribute p name, and I get Eric, or, and as you can see, the getter was called, or I can set attribute p name Alex, and as you'll see, the setter was called, and our dictionary again was mutated. The underscore name now is back to Alex. But you'll notice that the name property itself is not in the dictionary. That's because it actually is a class attribute, but when it gets called from the instance, the functions that correspond to what we're trying to do, get or set the attribute, the property, actually gets then called as a bound method. So if we look at our person class and we look at its dictionary, you'll see that name is in there, right? It's a property object at some location. Now, one thing I want to point out that's kind of interesting, and we've seen before where we can have instance attributes that mask the class attribute. So let's do that. Let's go ahead and create a new person. Let's say Alex. And so now we have p.name, okay? And if we look at the dictionary, well, it has underscore name. Now what we can do is we can also look at p underscore dictionary underscore name, right? We can access our private attribute this way, or we can just access it directly using that. Now, if we try and set the name, p.name equals Raymond, for example, then what happens is that the setter method was called and the dictionary still contains just underscore name. But remember that that dictionary for instances is mutable. So I'm going to do this. I'm going to say, okay, p done the dict, and I'm going to call this attribute name. So now I'm calling this attribute name, and I'm going to set that equal to, let's say, John. Okay, so now if we look at the dictionary for p, you'll see that we do have an attribute called name in the instance p, and then we also have the attribute underscore name. So if we do p.name, what are we going to get? Well, we're going to get still Raymond back. Even if we do the get attribute p name, and let me remove that, we still get Raymond. In both cases, the getter was still called. So even though we had an instance attribute that was on the instance that had the same name as the property that we have defined at the class level, Python will still use the property that's defined at the class level to get and set the value. So that's how properties work. Essentially, it's just a class level attribute that then contains a property object with basically settings for what to use for the getter, what to use for the setter. Now we can also have the deleter. So let's go ahead and just do that for completeness. Let's actually write a delete. So I'm going to take this code. I'm just going to copy paste it down here. And now we're going to create the deleter method. So def del name. So again, how we do this is completely dependent on how we want to do it, right? Python doesn't tell us what the delete should do. But as I mentioned in the video, the delete doesn't delete the property from the class. It's just going to run this code when we call delete on the attribute or the property at the instance level. So here, what I'm going to do is I'm just going to print deleter called, just so we can see that it's getting called. And what I'm deciding to do is that I'm going to delete basically the private variable, the private backing variable. So whenever the deleter gets called, this is what's going to happen. It's going to print this out, and it's going to remove underscore name from the instance dictionary, from the instance namespace. So I do need to specify it here. So I could say fdel equals del name. And as I mentioned, you don't have to use the keywords. You can just pass them in the proper order: getter, setter, and deleter. I'll leave the keyword arguments as is. So now I can create this person object. Let's call it Alex. And if we look at the dictionary for P, obviously we have the underscore name. We can access the name using the getter method. It returns the value. We can set it. We can say p.name equals Eric. That gets set. The setter was called, and of course we call the getter to get the new value. It is indeed Eric. Now we can say delete p.name. So this is how we could do it. We could also use the del attr function, and call it on P and then the string name. Here I'm just going to use the keyword. So if we do that, notice what happens. Deleter called, we get that print statement. So this function was called. Now, let's take a look at the dictionary of P. You can see it doesn't have the underscore name anymore. But if you look at the persons dictionary, it still has the name property. That hasn't gone, right? So if I try and call p.name right now, what is going to happen? Well, the property still exists, so it's going to call the getter method. It's going to call this method over here. So let's see what happens. We get the print statement, getter called, and then we get an attribute error saying that the person object, okay, the object, not the class, but the instance, has no attribute underscore name. Well, yeah, we just saw that. This dictionary is empty. What happened is that the second line of code here, this one here, is actually what failed because we're trying to return underscore name from the instance and it doesn't exist anymore. So what I'm trying to point out here is that when we use the delete, in this case, what happens is that we removed the private variable from the instance, but it doesn't delete the property from the class. So that means we can still now go back and call the setter. So we can say p.name equals Alex. That works. And if we look at the dictionary now, again, we have the underscore name back in there, and then we can, of course, retrieve the name. So that's how the getter, setter, and deleter works for properties. And we'll come back to how properties actually work. They're really more of a convenience, and we'll come back when we talk about descriptors later in this course. So the last thing I want to mention about this is the docstrings. Usually when we write code in Python, production code, we try and document our classes. We don't leave things kind of blank like that. It's not good practice, and it's not very helpful for people that come after us if they just want to know, what does the person class do? What is it used for? So in this case, I'm going to put a totally useless message, docstring. This is a person object. Okay, so normally we would have a multi-line docstring that would have more documentation about that and so on. And then what I want to do is I want to assign a docstring to the name property. So all I need to do here is basically set it in the property. So I can say doc equals, and then I'm going to say here the person's name. Okay. So I can specify the getter, the setter, the deleter, and a docstring for that particular property. So now when I do that, if I do a help on person, you'll see what happens. Oops. On the person class, you'll see that we get, this is a person object that came from the docstring that we defined here at the class level. And then we also have something that tells us that we have a name property. And of course, it tells us it's a descriptor. As I mentioned, we'll come back to that. And then the docstring that we specified. In fact, we could also just look specifically at the docstring for the attribute, for the property, by saying help person.name, and we'll get back just that docstring that we specified. So that's how we can specify docstrings for properties, at least one way of doing it. All right, thanks for watching, and I'll see you in the next video.